Hello, ladies and gentlemen. Today we're going to talk about solving exponential and logarithmic equations. Okay, basically we're going to talk about some ways that we can solve these certain problems and certain ways we can look at these things. Okay, so like for example, we actually know how to solve some exponential logarithms already. Like this first one here, we have 2 to the x. Let me zoom in a little bit. We have 2 to the x equals 32. We've solved this in the past by just saying, hey, 2 to what power gives me 32? And recognizing that, oh, x would have to equal 5. That's what would give me 32. So we can kind of solve that one just by kind of using some deduction and some logic, okay? We actually can solve this next one as well, the natural log of x minus the natural log of 3 equals 0. Now, you might be saying to yourself, Mr. Guy, I don't actually know how to solve that. That doesn't look like something we've done before, but we can actually use our log properties to simplify this side, make it the natural log of x divided by 3 equals 0, and then we can go ahead and use one of our log properties that we know, which is that if we have a log equal to 0, we know the inside has to be 1. So that means that x over 3 has to equal 1, meaning that x would have to be 3. Okay, so using our log properties, we can kind of solve that as well. Okay, where we're going to start running into problems are things like this over here, e to the x equals 7. Okay, so this is saying, all right, e to what power would give me 7? Now, I don't know about you, but e, remember, is an irrational number. It's like 2.7, blah, 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 blah. I don't know what power that raises to equal 7. In fact, it's probably an irrational number that it raises to give you that, okay? Same thing with this one over here, the natural log of x equals negative 3. Okay, well, when does the natural log of x equal negative 3? I don't know. It's going to be some really kind of crazy number that gives us that. How do I do that? And that's where the inverse properties are going to come in and help us, okay? So the inverse properties, basically what it means is that if I see a logarithm or an exponential, the inverse to get rid of them is by composing them with an exponential or a logarithm, okay? These are actually properties we talked about before. E to the natural log of x equals x, and the natural log of e to the x equals x. And this is true for all logarithms. So I use the natural log in e. It could be log in 10. It could be log base 2 and 2, whatever the logarithm or whatever the base is this applies for. Okay, so let's take that up here. How do I apply that to solve a problem like this? What you're going to do is you're going to take the natural log of each side. And what that effectively is going to do is to make this cancel with the e and make it so that it's x equals the natural log of 7. So what is the answer to this problem? It's the natural log of 7. Okay, and we could go ahead and solve and put natural log of 7 in our calculator to get a decimal approximation. Okay, so if I wanted to do that, the natural log of 7 would be approximately 1.95. And again, I'm going to round to 2 decimal places for this, okay, but about 1.95. Okay, and then with this one over here, I would do e to both sides. Okay, so e to both sides. And what that is going to do over here is get rid of this natural log. So x is going to be equal to e to the negative third, okay? And I can put that on my calculator. So e to the negative third is going to equal about approximately 0.0498. So about 0.0498. All right, so we can see how using this we can solve these problems now, very similar to how you would solve like a linear equation or things like that, using these inverse operations, these inverse things to solve it. Okay, let's look at a couple examples and things that you might be asked to do. So example number 1, here's an exponential equation we're going to try to solve. We're going to basically be following our order of operations backwards. So if you think of that, get rid of addition and subtraction, get rid of multiplication, division, and then the last one, exponents. That's kind of where we're at in terms of getting rid of using our logarithms and our exponentials to solve these. So I'm going to start here by dividing by 3 to get rid of that 3 that's being multiplied out front. And I'm going to get 2 to the x equals 42 divided by 3, which is 14. I'm then going to take the log base 2 of each side. And what that's going to do is that's going to get rid of this over here. I'm going to have that x equals the log base 2 of 14. Now, that is the exact answer. That is exactly what it equals. If I want an approximation, I would need to put it in my calculator. Remember, to do that, I'm going to use my change of base formula. So I'm going to do the log of 14 divided by the log of 2. And doing that, I would get approximately 3.81. Okay, around 3.81. And there's my answer right there. Okay? Let's look at another one. This one involves me solving a log. I subtract 2 from both sides. I'm going to get the natural log of 3x equals 2. I'm going to take e to both sides to get rid of this log. So I'm going to have 3x, because that's what's left over on this side, equals e squared. And then divide by 3, divide by 3. X equals e squared divided by 3. And again, that's the exact answer. Okay, that is exactly what it equals. If I want to give a decimal approximation, I just would go ahead and put e squared divided by 3 in my calculator. So e to the second power divided by 3. And I get approximately 2.46. Now you'll notice I'm giving a final answer that's exact, right? So an answer like this, and then I'm putting in my calculator to solve. You want to wait till the last moment you need to put in your calculator, especially when you're dealing with irrational numbers like we are with e. Anytime you put something in your calculator earlier and then start doing stuff with it, it's going to create more rounding errors so that your answer is going to be more off from my answer when you're done, okay? So if you ever notice, like if you solve a problem and you check the back of the book and your answer's off by like a little bit, like it's around the right answer but off by a little bit, probably a rounding error that's going on there, okay? So you want to be careful about that, okay? Let's take a look over here. All right, this one again, how I'm going to solve this. I want to start by trying to get the exponential part by itself. So I'm going to add 4 to both sides. I get that 2 times 3 to the 2t minus 5 equals 15. I'm then going to go ahead and divide by 2. I'm going to get 3 to the 2t minus 5 equals 15 halves. Now I'm at where the exponential is by itself. I'm going to take the log base 3 of each side. So I'm going to have the log base 3 of 15 over 2 equals 2t minus 5. So I'll go ahead and add 5 to both sides. And I'm going to end up dividing by 2 as well. So I'm going to get the log base 3 of 15 over 2 plus 5 divided by 2 equals t. And again, really kind of a gross answer, right? Oh, what the heck does that mean? That's my exact answer. I can get the answer in my calculator. Again, using that change of base formula. So we're going to say the log of 15 over 2 divided by the log of 3 plus 5, and that entire thing needs to be divided by 2. And I'm going to get 3.42. Okay? All right, let's do one more. We're going to go ahead and erase some of this stuff that we have there. And let's look at this last problem here involving logs. And this is where we saw this a little bit up top, but our kind of strategy for this one is if we can condense these logarithms into one log, we can then go ahead and use the exponential inverse and so we can get to a spot where we can simplify and solve, okay? So like I'm looking at this and I'm saying, you know what? These are both log base 6. I have subtraction. That's really like division on the inside. So I know that the log base 6 of 3x plus 14 divided by 5 is going to equal 2. Okay, so I'm condensing this to make it so that now I can go ahead and use my inverse operations. Okay, 6 to both sides. So 3x plus 14 divided by 5 is going to equal 36, because that's what 6 squared is. Okay, now I can multiply both sides by 5 and go through and solve this kind of like a normal equation. 36 times 5 is 180, so 3x plus 14 equals 180. And now we're just at a two-step equation. Subtract 14, 3x equals 166. And then divide by 3, x equals 166 thirds. Okay, and there we go. There's our final answer, and we're good to go. All right, so that's solving equations with exponentials and logarithms. Again, we're using them as inverse operations, basically doing the log of both sides or doing the whatever the base is as an exponent to each side to make stuff go away and cancel out. All right, thank you all for watching.